Hey guys, welcome to the Redis crash course. In this video I'll be going over the fundamentals of Redis. We'll talk about what it is, some of its advantages, the supported data types, and we'll get Redis installed and we'll go over some of the commands for the different data types. I do plan on building a Node.js app that uses Redis, but I don't think we'll get to that in this video. Okay, now some of this information, or actually all this information, is from a Redis course that I created with Edgewonix. In that course we talk about all this and more, and we do build a Node.js app, so I will put the link to that course in the description. Alright, so what exactly is Redis? Many of you may have never even heard of it, but it's a pretty awesome technology. It's an open source, in-memory data structure store, and it can be used as a database and or a caching system and a message broker. So if you really wanted to classify it as a certain type of NoSQL database, I think it best fits into a key value store. The structure is actually incredibly simple. Alright, so one of, if not the best feature of Redis, is the huge range of data types or data structures that it supports, such as lists, sets, and so on. And I'll be going over these in depth throughout this course. Redis is also has built-in replication, master-slave replication, that allows Redis servers to be exact copies of master servers. Masters can have multiple slaves, and replication is done asynchronously, meaning that the master will continue to handle queries when slaves are synchronizing. Alright, and I'm not going to really get into replication because there's a lot to it, and this is just a really basic guide on learning about what Redis is and learning some of the commands and how to set it up. So I want to focus more on that than stuff like replication and stuff like running Redis in production. Alright, so let's take a look at the data types that Redis supports. So we're going to cover these, the ones on the left mostly. The ones on the right are a little more complicated and beyond the scope of this course. So we have strings, which are the most basic kind of Redis value. A Redis string can contain any kind of data. Then we have lists, which are simply lists of strings, and we'll be going over all the commands to push onto lists and take strings off of them and so on. Sets are an unordered collection of strings. We can add, remove, and we can test for existing members of a set. Then we have sorted sets, which are non-repeating collections of strings. Okay, each member of a set is associated with something called a score, and we'll go on to that. We'll get into that later. And then we have hashes, which are basically key value pairs. These are the perfect data types to represent objects. You can almost compare hashes with JavaScript objects or JSON. When we build our Node application, this is what we'll mostly be working with. Alright, and then bitmaps and hyperlogs, these are actually based on strings but have their own set of semantics. Alright, we're not going to really get into that. It's more important for you to understand the ones on the left. Alright, so let's take a look at some of the advantages of Redis. It's incredibly flexible in terms of storing data. Just like many NoSQL databases, we don't need to define a schema or column names or specific data types for each value or anything like that. It's much different than SQL or relational databases, where everything needs to be defined before you can actually use it. Redis is also exceptionally fast. It can actually perform around 110,000 sets per second and about 81,000 gets per second. Alright, and as we saw, it supports rich data types such as lists and sets, and it's also both a caching system and a database that can persist data to the disk. So in my opinion, Redis is almost a mix of something like MongoDB, which is a flat-out NoSQL database, and then something like Memcached, which is strictly a caching system, not a persistent database. So we really get the best of both worlds. So let's take a look at what Redis can be used with. And I think a better question would be, what can it be used with? So this is actually from the documentation, and this gives us a list of all the languages and clients that Redis has. Alright, so you can see we have JavaScript or Node.js, PHP, Python. We have higher level languages like Java, C++, just about anything. So no matter what type of developer you are, whether you're a Java programmer or a PHP web developer, Redis is definitely worth learning. Alright, now as far as security goes, Redis was designed to be accessed by trusted clients. It's not something that you want to expose to the internet. It should be used internally. It does have security features like simple authentication, and you can restrict it to certain interfaces. Unfortunately, data encryption isn't supported. So again, only trusted clients should have access to your Redis database. Alright guys, so enough with the slides. We're going to go ahead and jump in and install Redis, and we're going to start to look at some of the commands and some of the data types. Alright guys, so we're going to set up Redis, and I'm on Linux Ubuntu, but Redis is cross-platform, so you can install it whether you're on Mac or Windows or Linux. Now, if you want to get it from the website, you can go to download at redis.io, and here you can download the tar.gz file, but if you're on Windows, you want to go down to where it says Windows and go to Learn More, and on the GitHub page, go down to this release page link right here. It's kind of hidden, and you want to grab the MSI file, and that's the Windows installer. Just run it, go through, click Next, and it'll get everything set up. Alright, now if you're on Debian Ubuntu like I am, you want to use your apt-get package manager. So let's say sudo apt-get update. Alright, and I'm just going to run sudo apt-get upgrade. Yes. Alright, and I made this really big, so hopefully you guys can see this, because we'll be working in the command line interface quite a bit. Alright, so now what I'm going to do is run sudo apt-get install redis-server. Okay, so once that's done, before we get started, I just want to copy the Redis config file, just in case we need to change that. So let's do cp, actually I want to do sudo cp/etc/redis/redis.conf, and we're going to put that in the same file, so etc/ or same folder, and we're going to call it redis.conf.default. Alright, so now that that's copied, you should be able to run the CLI by saying redis-cli. Okay, and your prompt should change to your server, and the default port is 6379. Alright, so Redis is now installed and running. We can clear the console by typing clear, and let me just minimize this because we're going to be working in the CLI for a while. So let's start with just some basics. So if we want to test to see if there is a connection that's still alive, we can say ping, and that's going to respond with pong. Okay, that lets us know that there is a connection with Redis. Alright, we can also echo things out, and it's common convention to use caps, but you don't have to. And we can echo out, let's say, hello world, and that echoes out the string. If we want to close the connection, we can say quit. I'm not going to run it because I don't want to close it, but we can. So let's start out with get and set, and this is really simple. We'll basically just set a key value pair. Okay, so let's say we want to set, and let's just call this, we'll just call it foobar, or just foo. Alright, so let's set this foo to a value, and we'll set it to 100. And it can be a number or it can be a string, and we get OK. So if we want to get that, we can simply say get foo. Okay, really simple. If we wanted to set, let's see, set bar to, we'll just say hello world. Okay, and we can go ahead and get bar, and we get hello world. So that's get and set, very simple. We can also increment numbers, so we have the 100 in foo, so we could say incur, and say incur, what I call it, foo, and that gives us 101. So now if we get foo, that's going to be 101. it just increments it by 1. If we want to bring it back down, we could say decker foo, and that brings it back to 100. We can also check to see if something exists by saying exists foo, and you'll see that gives us a 1. If we say exists foo 1, we get a 0 because we didn't set that. Now if we want to get rid of a key value pair, we could use del. So let's say del, we'll delete bar. So now if we say exists bar, we get a 0. Alright. And if we try to get something that isn't there, so let's say get bar, we're going to get nil, okay, which means that nothing's there, it's empty. Now if we want to clear everything out entirely, we can use flush all. Okay, so if we do that and now we try to get foo, which we didn't clear out, you'll see that it's not there. Okay, anything that we had set up to that point is going to be gone, flushed out. Alright, now when you're saving key value pairs, you can also use key spaces. So let's say we wanted to set, let's say we have some server info, we could say set server and then colon name, and we'll set that to some server. Okay, and then we could say get server name, and that will give us some server. And then let's say we wanted to set the port, or we could say set server port and set that to let's say 8000. Okay, so then we could get server port. Okay, pretty simple. We can also set values to expire at a certain point. So let's say let's set, whoops, okay, let's set, we'll say greeting, and we'll set that to hello world. Okay, we can get greeting. Now if we wanted this to expire at a certain point, or a certain number of seconds, we could say expire greeting, and we'll say 50. Okay, and that will expire in 50 seconds. Now if we say TTL, what did I call it, greeting, that'll give us the amount of seconds that are remaining. You'll see that had 40 seconds. If I run it again, 35, so it's counting down. Alright, and then it's going to just expire completely when it gets to 0. Alright, so we'll just let that count down. 14 seconds, 9, 8, 2, 1, 0. And now we get -2. Okay, and if we say get greeting, that's nil, it's gone. Alright, so that's how you can set expirations. So let's clear this out. Now if we want to set the expiration along with setting the actual value, we could use set x. Okay, so set x, and then let's say greeting, and then we want to put the number of seconds we want. We'll say 30, and then we want the value, so we'll say hello world. Okay, and then if we do our TTL greeting, you'll see that it's counting down again. Alright, so that's if you want to set the value and the expiration at the same time. Now if you set an expiration and while it's counting down you want to basically take away that expiration and persist it, then you can use persist. So let's go back to this right here, and let's just set this to 130. Alright, and if we say TTL greeting 126, now let's say persist greeting, and then if we do our TTL, you'll see -1 because it's not going to expire at all. And if we say get greeting, you'll see it's still there. Alright, so we've gone over get and set, but the get set will only set one value. If you want to set more than one key value pair, you can use mset. Alright, so let's say mset, we'll say let's do key 1, and we'll set that to hello, and then let's say key 2, and we'll set that to world. So now if we get key 1, we get hello, key 2, we get world. So you can set more than one pair in one command. We also have a command called append, where we can append one onto another. So let's say we want to append to key 1, and we'll just say space world, and now we'll say get key 1, and we get hello world. Now we can also rename keys or variables, whatever you want to call them. We can say rename, and let's rename key 1 to greeting. So now if we say get key 1, there's nothing there, but if we say get greeting, we get hello world. Okay. Alright, so now what I want to do is get into data types other than just strings. So we're going to start with lists. I'm actually going to pull up the documentation here, and let's search for Redis list. Let's see, data types. Okay, so a list is simply a list of strings sorted by insertion order. So we can add to a list by using lpush or rpush. So if we look at lpush, and like I said, the documentation is pretty good. Any command you want to look up, you can see what it does. You can see some examples. Alright, so this will insert all the specified values at the head of the list. Okay, so at the beginning, and then rpush will push it on to the end. So let's say we want a list called people. So let's say lpush. Actually, I'm going to just flush all before we do this. Okay, and then we'll say lpush people, and let's add Brad. Okay, so now we have a list called people which has one value in it, and that's Brad. So let's add another person. So we'll say Jen, and let's add another one. We'll say Tom. Okay, and then this is returning the number of people that are in the list. Now if we want to output the list, we can use the lrange command. So let's say lrange, and we want our list, which is people, and we want to say from 0 to -1, which is going to give us everybody. Okay, so you can see Tom, Jen, and Brad. We can specify our range, so that will give us everybody, but if we want to say 1 and 2, that gives us Jen and Brad, and the reason for that is because it's 0 base. So Tom is at position 0. Okay, Jen is 1, Brad's 2. And notice when we did lpush, it pushed it on to the beginning. Okay, Tom was the last person we pushed on. If we want, we can say rpush onto people, and let's say I don't know, Harry. Okay, so now if we do a range and we look at everybody, you'll see Harry was added on to the end. Okay, it was added on to the right. We also have this len, where is it? Right here. And this will return the length of the list stored at a certain key. So let's say len Jen. Whoop, did I do that right? Oh, we didn't do the name of the list. People Jen. Wait a minute. len my list. Okay, so that gives us, that's not right. It gives us 4. Oh, so it just gives us the length of the list in general. I thought it did something else. Sorry about that. Alright, so that's len. Now we can also use lpop and rpop, and those will basically remove from the front or the back. So if we say lpop people, we get Tom because that's what it's going to remove. Okay, if we want to now look at the list, you'll see Tom was basically popped off from the left. If we do rpop people, we get Harry, and now that popped off of the other side. So now we only have Jen and Brad in our list. Now let's say we want to insert in the middle here, and we don't want to insert from the left or right. For that we can use linsert. So let's say linsert people, and we're going to say before Brad, before Brad, and then Jen. And now if we look at our list, oops, that's not right. Here it is, before Brad, but I added another Jen. Alright, so let's do lpop people. Alright, so now we just have Jen and Brad. And let's go back and do the insert, and we'll say before Brad, Tom. And there we go. So that inserted Tom before Brad. Okay, so now he's in the middle. Alright, so that's lists, and these are the commands that go with lists. And you can look up these. There are more. I'm not going to go over every single command. If you want to get more in depth, I'd suggest watching the Eduonics course that I'll link in the description. So let's go ahead and flush all, and we're going to just clear this. And now we're going to take a look at sets. Okay, so let's say Redis sets. And let's see, let's go down here. So a set is an unordered collection of strings. It's possible to add, remove, and test for existence of members. Okay, so let's see, let's look at SAD, S-A-D-D. This will add specified members to the set stored at key. Alright, so let's go ahead and say SAD, S-A-D-D, and we'll call this list, or this set, cars. Okay, we're going to add, let's say, Ford. Okay, you'll see that returns a 1. Let's add another one. We'll say Honda. And let's add, let's say BMW. Okay, so now we have a set with 3 members. So let's look at the command sysmember, and this will return if a member is a member of the set stored at a key. So let's do sysmember cars and Ford. Okay, so that's going to return a 1. If we search for, let's say, Chevy, we get a 0 because there is no Chevy in our set. We also have a command called smembers, and that's going to return all the members of the set. So let's do members cars, and that's going to give us all the members of the set. We also have scard, so returns the set number of elements. So let's do scard cars, and that gives us 3. Okay, so that gives us how many elements or how many members there are. We can also move a member to another set if we want. So let's say smove, and we want to move from cars to, let's say, my cars, and we want to move Ford. Okay, so now if we do smember cars, you'll see that 4 is gone, but if we do smember my cars, there's Ford. If we want to just remove a member from a set, we can use srem. Okay, so we'll say srem from cars, and let's specify BMW. Okay, so now if we look at cars, it only has Honda. BMW's been removed. Alright, and there's some other things we can do as well. sdiff will return the members of a set resulting from the difference between another set. We have, what else? spop, which will remove and return 1 or more random elements from the set. I'm not going to do all of these, but just know that those are available for sets. So next we have sorted sets. I'm going to flush all here, and let's clear, and let's look at sorted sets. Let's see, documentation. Let's see, where is it? data types, strings, we already went over that stuff. Lists, okay, all stuff we just did. And let's see, hashes, we're not going to do that just yet. Where's sorted sets? Alright, we'll just search for it. Redis sorted sets. Oh, maybe it doesn't have its own section. Right here, sorted sets are similar to Redis sets. The difference is that every member of a sorted set is associated with a score. Okay, let's see. That is used in order to take the sorted set ordered from the smallest to the greatest score. While members are unique, scores may be repeated. So a member can have a score, that another member has as well. Alright, so let's take a look at some of these. So we have ZADD or ZAD. This is just like SAD for the regular set, except this is for sorted sets. So let's say that we want to add, we'll say ZAD, and let's call this users. So we'll call the set users, and then we want to define a score. And what we're going to do is we're going to set the user's birth year as the score. So let's say 1980, or let's do 81, and I'll put my name. Okay, so that's going to add it's going to add this user to our sorted set, and has the score of 1981. Alright, so let's do another one. We'll say John Doe, and let's say 1975. Okay, we'll add another one. Let's say Mike Smith, and let's say 1990. Alright, so now we have a couple members in our sorted set. And just to show you, we can have the same score for multiple people. So for this, let's say Kate Rogers. Alright. So let's look at zRank. So zRank will return the rank of a member in the sorted set stored at a certain key with scores ordered from high to low. So let's do zRank people, and let's say Mike Smith. Oh, it's not people, it's users. Okay, so that gives us 3. Let's say zRank John Doe, and that gives us 0. So the reason for that is because John Doe's score is lower than the rest of them. Alright, so if we do me, we get 1. Okay, so it's just the rank in order of the score. Let's clear this out. So we also have zRange. So let's do zRange users 0, -1, and that'll print out all of the members in the sorted set. We can also increment, so we can say z incr by, and let's say we want to increment, we have to say the name of the set, so incr by users, and let's increment by 1, and we'll say John Doe. Okay, so now John Doe is 1976, and we can do more than 1 as well. So if we say by 10, now it's 1986. Alright, so I'm going to flush all and then clear it, and we're going to now look at hashes. Alright, so let's say Redis hash, and actually I want to look at hset. Okay, so hset will allow us to basically create a key value pair within a hash. Now let's say we want to create a hash for each user. So we can use hset, and then let's say user : Brad, and then name, and then we'll say Brad Traversy. Okay, so we have a hash called user Brad, and we set the name value to my name. Okay, so if we wanted to set something else for user Brad, let's say email, and we'll change this to, let's just say brad@gmail.com. Now we have a user that has a name and an email. And if we use hget, so hget user Brad, I want to say hget user Brad and then name, and we can get user Brad's email as well. Now if we want to get everything, we can use hget, is it hget all? Yeah, hget all, and then user Brad. Okay, and that'll give us the key name, the value, the key email, and the value. So when we build our Node.js application, this is what we'll be using as a hash. Now if we want to set, let me just clear this out. If we want to set multiple values at the same time for a user, we can say hm_set, and let's say user, we'll say user John, and we'll set the name to John Doe, and then let's set email to jdoe@yahoo.com, and let's also set an age of 25. Okay, we get OK, and now let's do hget all for user John, and that gives us the key and the value for all the data we set. And if we want to get just the keys, we can use hkeys for user John. That gives us all the keys. We can also do hval, which or vals, which gives us just the values. We can also increment, so let's say incr by, and we want to put user John, and we want to increment age. Let's see, and then 1, and then that brings the age to 26. Okay, we can also delete values. So let's say we want to delete the age altogether. We could say hdel for user John, and we want to delete the age. Whoops. Age. Okay, so now if we do our get all, you'll see that John doesn't have an age anymore. We also have hlen. So if we say hlen user John, that gives us 2. It lets us know the number of key value pairs that it has. Alright, so that is the hash data type. Okay, let's clear this. So those are the main types of data, okay, the main data structures: lists, sets, sorted sets, and hashes, and of course strings. Now when we build our Node.js application, I'm not exactly sure when that's going to be. It could be my next video or maybe a little down the line, but the commands we learned, such as hget, hset, we can use those with the Node.js driver. Okay, so it's important for you to know those commands. What I want to do now is talk a little bit about data persistence. There's a few different ways to do it in Redis, so let's search for Redis data persistence. Alright, and let's take a look at this. So Redis provides a different range of persistent options. RDB persistent performs point-in-time snapshots of the data set at specified intervals. Okay, so that's one way. And then we have the AOF persistent, which logs every write operation received by the server. So this is a little more solid than the snapshotting. Okay, and this page gives you a lot of information as far as the advantages of RDB over AOF, and you can use both. Okay, you don't have to pick just one. But basically with snapshotting, we can use the save command, and we can run that at any time. So we know we have some users. We have the user John and user Brad. So let's just go ahead and say save, and that's going to create a snapshot of that data onto disk. And then you can also specify intervals here. So if we say save 60,000, this is going to save it every 60 seconds if at least 1,000 keys have changed. Okay, so you can manually save. You can also set up snapshotting intervals. Alright, now when this data is saved, it's going to be in a dump file, which is going to be in, let's see, var lib, and we go down here to Redis, there's a dump.rdb file. So if we open that up, I can't open it with gedit. I'll select application, and let's open it with gedit. Alright, and then here you can see it's not very readable, but you can see that our user John is there and our user Brad is there. So it took a snapshot of the data and saved it to disk. Okay, now you can set up some kind of backup system like RDiff, which I do in the course. I'll show you how to do that in the Eduonics course, and you can back this file up every whatever you want. Okay, so that's one way to do it. Now this append only file, this will basically log every single thing you do, and you can set this to yes in the config file. And this is in the Etsy folder. Let's see, Etsy, and we should have a Redis folder here. Right there it is. And we have our conf. We also have the backup we created in the beginning. Let's see, we can't open this here. Let's actually go to our terminal. Actually, I'm going to open up another one. Alright, so from here, let's go cd etc Redis, and let's say sudo nano redis.conf. Alright, and from here, this is our main configuration file for Redis. You can see we have the port, and we should have the AOF option somewhere in here. What the hell is it? Alright, let's do Control W here and search for AOF. Where is it? Let's see. Oh, append only. That's what we want to search for. Okay, so right here you'll see by default append only is set to no, but we could simply change that to yes and exit and save. Okay, so now we'll use append only. So now we have the snapshotting and the AOF persistent method set up. Alright, and there's a little more to it. Well, there's a lot more to it if you want to really go in depth, but basically that's pretty much the fundamentals of Redis, all the basic commands, the data types, persisting to disk. And like I said before, what's great about Redis is that you can use it as a simple caching system, or you can use it as a full-fledged database like MongoDB or something like that. Okay, and it's incredibly fast. So hopefully you guys learned a little something here and you enjoyed this video. Like I said, we will be building an application using the Node.js driver for Redis. I'm not exactly sure what the project will be yet, and it'll be pretty simple, but you'll learn a lot from it. Alright, so if you guys aren't subscribed, please do so. Please leave a like if you liked the video, and also if you want to look more in depth on Redis, then check out the course in the description. Alright, thanks for watching.